Welcome students, this is Ravi Shankar. Today we are going to study about the next concept, and the next concept that we are going to study today is called to be electrostatic shielding. What do you mean by this concept? Electrostatic shielding, protecting, that called to be shielding. So we are going to study about a concept called to be electrostatic shielding. What do you mean by this concept called as electrostatic shielding? And very interesting topic. See, when you are considering this concept or when you are taking this concept called to be electrostatic shielding, we have already studied in Gauss law. See, according to the applications of Gauss law, we have proved that the electric field inside a hollow sphere is zero. Similarly, we have proved that using the conductors in electrostatic equilibrium, the electrical field E equal to zero in both solid and hollow conductors. Isn't it? We have proved the electrical field is equal to zero inside, not inside both solid and in hollow conductors. That is, electrical field is equal to zero. Based on this concept, this electrostatic shielding is explained. See, what do you mean by the literal meaning? What is the physical meaning or the literal meaning of this electrostatic shielding? It is nothing but protecting an area from the electrical field. Literal meaning is protecting an area from electric field or from electrical lines. Protecting an area from electrical field. This we are calling it out as the literal meaning of this electrostatic shielding. So in order to explain this, let us consider a conductor of any shape. If you are considering a conductor of any shape and this conductor is being given with the positive charge, okay, conductor is being given with a positive charge, then the external electrical field will be acting perpendicular to that of the surface and radially outwards. To the surface, the lines are perpendicular. Since the charge available inside is considered to be, since the charge available inside is considered to be positive, then we can say they are acting outwards. But at the same time, if you are taking the charge inside this conductor is taken to be negative. Inside this, instead of positive charge, if you are having the charge as a negative, then the direction of this electrical field will be towards. But whatever may be, the electrical field lines or the electrical field is always perpendicular to that of the surface, studied in our last video regarding the properties. Now, what I have to consider? I am considering a small cavity inside. Inside this conductor, you consider a small cavity. See, inside this cavity, then the electrical field E equal to 0. So that inside the conductor electrical field is 0. So we can say inside the cavity. So considering a cavity inside the conductor, then the electrical field is zero. Then the electric field is equal to what? Then the electrical field is equal to zero. See, while doing experiment, any of the electrical instruments which is more sensitive to external electrical field, if it is placed inside this cavity, it is found to be unaffected. Isn't it? See, any sensitive electrical instrument to protect from external electrical field, that can be kept inside the cavity so that it is considered to be unaffected. So this phenomenon is called to be electrostatic shielding. Okay, so this phenomenon I am writing here. So this process or phenomenon, this phenomenon is called as electrostatic shielding. See, can you define it out? See, in your book there is no definition given, but what we can do is we can able to define. How you can able to define? See, definition. Let us consider the definition here. The process, or I can write the phenomenon of protecting or shielding and a small area from external electrical field, is known as electrostatic shielding. Are you clear? So we can say so many examples. One of the examples we are calling it out as Faraday's gauge. What do you mean by this Faraday's gauge? This Faraday's gauge can be used to demonstrate this electrostatic shielding. See, usually it is made up of metal bars. Okay, you will be having a box which is being made up of metal bars. And if it is made, after that, a person or any other instrument is being placed inside. Let us consider a person is being placed inside this metal gauge. See, artificial lightning is made to cause. Artificial lightning is produced. When artificial lightning is produced, it was found out that the man inside the gauge is found to be not affected. This is one of the example. So usually based on this, a 3-mark question or a 2-mark question may be asked, either a 2-mark or 3-mark. What is that question? See, why it is safe, or how you can able to protect a person during lightning when thunderstorm is occurring. So there is a concept called to be where to place a person during thunder or storm accompanied with the lightning accompanied with lightning. Okay, let us consider. See, you are having a rain followed with a thunderstorm accompanied with the lightning. Now we have to say where to place a person safe. Whether I have to keep him under a tree, or I have to place him in an open ground, or inside a car or a bus, Like this, a question will be asked. Where to place a person safe during lightning, whether he has to be placed under a tree or in an open ground, inside a car or a bus. What is the answer? See, in order to safeguard or protect a person, from lightning, he should be placed inside a car or a bus rather than under a tree or in an open ground. Why? Because during the lightning, the charges flow through during the lightning. Okay, we can say during the lightning, the charges, the charges flow through the body of the conductor, flow through the surface or through the body of the conductor, surface of the conductor or the body of the conductor, to the ground or to ground with no effect on the person, inside. This we are calling it out as the concept or the example relating electrostatic shielding. Shall we recall? You see, what I have considered initially, I have considered a concept called to be electrostatic shielding. What do you mean by this concept called as electrostatic shielding? See, according to the application of the Gauss law, we have studied or proved that the electrical field inside the hollow sphere is zero. Similarly, we have also proved from the conductors of electrostatic equilibrium, the electrical field is zero inside both the solid as well as the hollow conductor. So what is electrostatic shielding? I have written it in this box. Protecting an area from electrical field. Inside that area, electrical field should not act. So in order to explain this, let us consider an conductor. See, when you are considering a conductor, in this conductor, you are having the positive charges. So electrical lines of forces are acting radially outwards. If the electrical field are acting radially outwards, means the charge is positive and the electrical lines or electrical field is perpendicular to that of the surface. If it is negative, it will act towards or inwards. Inside this conductor, you consider a small opening or a cavity, a hole like that, a hole. See, if you are considering a cavity or a hole inside the conductor, inside that cavity, according to the concept, electrical field is zero. If any of the electrical instruments which is more sensitive to external electrical disturbances is placed inside this cavity, it is found to get unaffected. So we are considering a cavity inside the conductor, then the electrical field inside the conductor is 0. And if any sensitive electrical instrument which will get affected by the external electrical field, if it is placed inside this cavity, it is found to be not affected. So this phenomenon, because inside the cavity electrical field is 0. So the external electrical field is not available inside this cavity. So this phenomenon of protecting or shielding an electrical instrument is called as electrostatic shielding. So we can define it. How we can able to define? You see, the phenomenon of protecting, or shielding a small area from the external electrical field is known as electrostatic shielding. For the two examples are being given. One is the Faraday's gauge, another one is in order to safeguard a person, he has to place himself inside a bus or a car. What do you mean by this Faraday's gauge? A gauge made up of metal bars. A person is made to sit inside or place inside this Faraday's gauge, and an artificial lightning is made to occur. And it was found out that the person inside the gauge is unaffected by the lightning charges. Then the second one, how it is safer or why it is safer to place a person inside a bus or a car to protect himself from lightning instead of placing him under a tree or in an open ground. So I have written it here like this. See, where to place a person safely during thunderstorm accompanied with lightning or during lightning. Whether he has to be placed under a tree or in an open ground or inside a car or a bus. May be asked in an one-word question also. See, in order to safeguard or in order to protect a person from lightning, he should be placed inside a car or a bus rather than under a tree or in an open ground. The reason is, during lightning, the charges that were coming out or the charges that were being discharged from the lightning will flow through the metal surface or through the body of the metal body of the conductor to the ground with no effect on the person inside. So the person is safe inside the bus or a car during lightning. Hope you should have understood the concept. Let us see the next class in the next video regarding electrostatic induction. Thank you.